Okay, Mario, once again, Wednesday, August 27, 2025. I just did a short video on these motors here that I am working on, trying to get these motors to some level of operational state that I can reuse them in the 4-inch, 6-inch disc sanders by Delta. I show that in some other videos. But anyway, I was going to replace, at least on one of the machines, I was going to use just a dishwashing motor that I took out from an old dishwasher. But after looking at the how complex the assembly was going to be, I decided to not to go that route. It's bothering me, and I'd rather just keep the same architecture of the motor. I really like these motors, so you can see how nice and clean they are, and they're fine. The motors are fine. It's just that they don't have the startup winding because they burn, as I'm showing in this second motor here. So this one I already cleaned this motor several years ago, but I put this project aside, and so I'm coming back full circle again to try to see if I can just finish this and complete and get these motors back on the machines at least, so that I can run them direct, with an AC line connected directly to the run coil. The only thing with that is that you got to start the motor manually, so that's an option. Typically you want to have it automatically turn on, run the motor automatically through some circuitry, but if that's not feasible, this is an option here. The motor that you see here is, as you can see, it already has this these I don't know, this type of retainers. This is it's cord. It's just a cotton cord that twisted cord that gets wrapped around these coils, just to retain them more securely. I guess, motor winding is done that way. Has been always been done that way. With these these materials here. So I'm just going to remove all this. I already started on the other side, so that's gone, and we may as well just do it on this side right here. Where's my cutter? So I am just going to remove all these, also all these nylon tie wraps. They're kind of falling apart here from the heat. And so the way this is connected here, before I undo this, I'm just going to show it in this video. We have basically 3 wires here, and according to my diagram that I show in my short video, I'll pull my camera over here. You can see the diagram right there. There are 2 connections here that happen on the happens on the white connection here, the return to the AC plug here. So from the AC plug, one connection that goes through a black wire, it gets connected to the switch. The switch, the other side of the switch, gets connected to a red wire that gets connected to this solenoid coil relay. It's just a magnetic contactor. When it gets energized, it makes contact via these contact points right here, and it also sends current to the secondary coil, that coil that I'm about to remove, the one that's burned. That is actually the startup coil, or the resistance start coil. I guess that's what it's called. By the way, these motors are also called the single phase, split phase, because it's a single phase type motor, operates on 120 volts AC, but the phase split via this circuitry here in order to get the motor to electromagnetically shift a little bit of the phase, so that you can get that oomph, to get the motor started electronically. But if you don't have that circuitry, you can certainly connect this to the AC cord directly, and just get it started manually. I am going to do that eventually on this motor, because I want to get these motors back on the machines, and I don't want to spend too much time on circuitry, designing circuitry, or modifying motors, or modifying the case of the machine to install larger motors. Whenever you use the same type of motors in the case, this is fine. I'm going to test this one also, make sure the larger coil is fine. I believe it will be. As you know, my experience with this other one has shown, that the coil of the burn is the skinnier one, and the larger one is just fine. And so I will be installing also a fused direct in line with the main switch, just for safety, or a circuit breaker in line with the switch in case something goes wrong. You don't want to create a short or a fire, God forbid. So safety is paramount. When you're doing these things. And when you're going direct, to the wires, you got to have some safety in line with those connections. So that's what I'm going to do with these motors here. And like I said, I'm just going to manually start them. Once they're in the machine with the belt itself, you can just move the belt. Give it a good shove, and then that'll get the motor started. And so at least I can get some more use out of these machines without having to invest too much time on, like I said, rewinding the motor. I could rewind these motors, with this type of coil, magnetic coil, or wire. But as you can see, it's quite complex, because I have to go through every single one of those little crevices that retains these coils. I did a diagram when I took this motor apart, that shows the number of windings. So I did all that. In fact, somewhere here is probably my, you can see that diagram here. I kind of made a sketch of the coils, how many turns each coil would have. It's kind of mirror image here, and length of each coil. So I could do that, because I do have that information, but I'm not going to do that because it's just a lot of work. And so I am just going to remove this. As I was saying, according to the diagram right here, this red wire here, that's part of the motor connection that goes into the switch box. It's this red wire. This red wire is connected directly to the skinny wire, which is the startup coil, which would be the red right here. So I show here in this schematic, the red. So that's coming out from the actually from this coil here. So that red is that line right there. The white right here has two connections here. It has both the. You see? Does it have both of them? Yeah. Yeah. Yes, you can see that. Oh, my camera is not. Here, let me put my camera on top here. Okay, so this white connection has two wires, has the skinny coil and also the thicker coil. So both of them are these are the return lines, from the AC plug. So those are those two lines right there that I show connected to the white line return, and the black is connected to the larger coil. As I show here in this diagram, the black is connected to the larger coil right there. So that's a better view of my diagram right here. I don't know, for some reason my camera is acting up. It's not registering. It's not trying to focus properly. Okay, so with that understood, now we can move into just cutting these wires here. So I'm just going to remove this. Let's see. I do need the extra length on this wire here, so I'm just going to cut this sheathing to expose the solder point. Okay, because I want to retain this length of this cable here. This is a rather short connection, so so that I can do the same thing I did right here. As you can see here, you see that? That's the short line that I'm working on this motor coil right here. So that's that line right there. So I'm just going to cut this like that, and I'm going to cut this also. Let's see. Okay, I'm going to cut this right here. And I typically like to leave the, when I'm working on motors, something similar, I like to leave the sheathing on the end of the wire, so that I know what color wire went to which coil. This cable, I will save that, because we're going to have to reuse that once we do the connections again. So now that this is all a little bit cleaned up, now I can just come back and just lift these coils up and just remove them. Just cut them. It's a lot easier to cut the coils, and if my cutter can cut through these coils here. This cutter is supposed to cut through copper. Okay, I think my cutter's a little bit yeah, my cutter's weak. It's the edge has worn out. Okay, so I'm just going to use this heavier duty one, not mess around with it. I do have a cutter, a more industrial cutter, but I think that's in my shop. Okay, so I'm not going to do this. I'm going to take my time outside this video, but just to give you an idea how this needs to be done. And so I'm just going to remove all this skinny coil, which is the startup coil that burnt, and just leave the main run coils here. Look how easy this comes out once you start lifting these things, and then you just take your cutter and cut right through that. Same thing here. You just lift this up. And when I did my first one, I had to go through every single coil right there to count the number of turns and count the length, because not every coil is the same length, because one wraps on top of the other. A section wraps on top of the other, and that's the reason why my schematic shows it this way. 24 turns, but that one was 13 inches long, 11 inches long, 9.5 inches long, 7 inches long. And it's because of this reason, because these things are staggered, so they're not the same length. The turns are the same on all of them, 24 turns up per coil here. And there's 1, 2, 3, 4, 5, 6, 7, 8. There's eight coils, 24 turns each, but they're different lengths because of the staggering factor. Okay, so I am going to stop this video. Oh my God, this is getting really messy here. My hands are getting dirty, filthy. So I will do this off camera, and in my next video, I will just show you the motor basically cleaned up and reassembled. It'll be basically like this one here with these two wires sticking out, and then you can just simply connect the AC line and just give it a good start, and the motor will start. Like I said, not a conventional way to start these motors. But it is a way to get the motor back in at least somewhat working order back into these machines, to get a little more life out of them. Mario, once again, stay tuned for more.